Hello everyone, my name is Rela Dinesh from CSITA section. I selected topic is Cayley-Hamilton theorem for roboticists code AHSC02. Let's see our agenda first. What is Cayley-Hamilton theorem? Who discovered Cayley-Hamilton theorem? Applications of Cayley-Hamilton theorem. What is roboticist? Fifth one, matrix functions of Cayley-Hamilton theorem. Sixth one is conclusion. Then see what is Cayley-Hamilton theorem. In linear algebra, the Cayley-Hamilton theorem states that every square matrix over commutative ring such as real or complex number or integer satisfies its own characteristic equation. If A is a given n cross n matrix and log is the n cross n identity matrix, then characteristic polynomial of A defined as P base A lambda is equals to det lambda I base n minus A, where det is determinant operation and lambda is variable of scalar element of the base ring. Since the entries of matrix display style lambda I base n minus A are linear or constant polynomial in lambda, the determinant also a degree n monic polynomial in lambda. It given as P base A lambda is equals to lambda power n plus C base n minus 1 lambda power n minus 1 plus C dot plus C base n I C base 1 lambda plus C base 0 minus dot. Here finish that equation. Now P base A lambda equals to lambda power n plus C by n minus 1 lambda power n minus 1 plus C dot plus C base 1 lambda plus C base 0 minus I. Now we see who discovered Cayley-Hamilton theorem. Arthur Cayley from 1821 to 1895 is widely regarded as Britain's leading pure mathematician of 19th century. Cayley is 1848 went to Dublin to attend lectures on quaternions by Hamilton. They discovered later Cayley impressed him by being the second published work on them. Cayley proved that theorem for matrices of dimension 3 and less, publishing proof for two-dimensional case as for n cross n matrices. And Cayley stated, I have not thought it necessary to undertake the labor of a formal proof of the theorem in the general case of matrix of any degree. Okay. This is a picture of Arthur Cayley. Now we see for Cayley-Hamilton theorem, there are two discovered. First one is Arthur Cayley and another one is William Rowan Hamilton. Now we discuss about William Rowan Hamilton. 1805 to 1865. He is physicist, astronomer and mathematician. First foreign member of American National Academy of Science, while maintaining an position about how geometry should be studied. Hamilton always remained on the best term with Cayley. Hamilton proved that for a linear function quaternions there exists a certain equation depends on linear function that is satisfied by the linear function itself. Now we see application of Cayley-Hamilton theorem. The Cayley-Hamilton theorem is used in proof of theorem of Jacobson. Cayley-Hamilton is a part of what makes the Wiedemann algorithm. Cayley-Hamilton useful to calculate eigenvectors of square matrix given eigenvalues without having to solve any additional equations. Cayley-Hamilton theorem can be used to prove Gelfand's formula. Cayley-Hamilton can be useful in commutative algebra. It is used to derive all polynomial identities of the ring of matrices from the Cayley-Hamilton theorem. Cayley-Hamilton theorem can be used to prove classification of finite dimensional real division algebras. Okay, now see what is robotics. Roboticists are generally involved in design, programming, construction, and testing of robots. They can work on stage of development from creating software to building hardware and troubleshooting the finished product. It is not necessary to have in-depth knowledge of every stage, however, there are many places where you can join the team. Wong says, it does not matter if you are excellent at building but not so great with software. We get experts from all different fields and we need them to work together. Okay, now we talk about Sophia. Sophia is a humanoid robot which we know all of them. Okay, now see about that robot. Sophia is a social humanoid robot developed by Hong Kong based company Hanson Robotics. Sophia was activated on February 14, 2016 and made its first public appearance in mid-March 2016 at South by Southwest in Austin, Texas, United States. Sophia has been covered by media around the globe and has participated in many high-profile interviews. In October 2017, Sophia was given Saudi Arabian citizenship and became the first robot to receive citizenship of any country. In November 2017, Sophia was named the United Nations Development Programme's first innovation champion and is the first non-human to be given a United National title. Hamilton theorem. Now we see matrix function of Cayley-Hamilton theorem. Cayley-Hamilton theorem has more matrix functions which help us in robotics. Shall we discuss some of them? These matrix functions are used in roboticists for developing software in the robots. Okay, now we see characteristic equation that AB square n by n matrix or n cross n matrix. Its characteristic equation is that of A that into A minus lambda I is equals to 0. Then we see second polynomial equation of degree n. This is a polynomial equation of degree n, whereas A degree n plus A base n minus 1 lambda power n minus 1 or degree n minus 1 plus up to A1 lambda plus A naught is equals to 0. Then third equation, characteristic equation of eigenvalues. The roots lambda I of characteristic equation are eigenvalues of A. Then the matrix satisfies its own characteristic equation. Whereas A power n plus A base n minus 1, A power n minus 1 plus up to A base 1 A plus A naught I is equals to 0. Okay. Now we see corollary 1, which is a matrix polynomial. Fourth equation. Any matrix polynomial in A of degree greater or equals to n can be written as matrix polynomial of degree less than n. This is because the higher power of A can be written as sums of the lower power with A power n equals to minus A base n minus 1 capital A n minus n capital A power n minus 1 minus up to minus ai not minus a 1 capital A minus a not I. It is a fourth equation. Now we see corollary to matrix. It is a matrix inverse. The inverse of a non-singular matrix A can be written as matrix polynomial of degree less than n, whereas A inverse equals to minus 1 minus 1 by A naught into A power n minus 1 minus A base n minus 1 by A naught into capital A power n minus 2 minus up to minus A 1 by A naught into I. Now we see sixth equation. The Cayley-Hamilton theorem can be used to extend scalar functions of scalar arguments to matrix functions of matrix arguments. Any analytic scalar function f of x of scalar argument x can be extended to a square matrix capital F of a square matrix argument A with corollary 1. The matrix function f of a can be written as polynomial p of a of degree less than n. Now this equation indicates that f of a equals to p of a equals to p base n minus 1 capital A power n minus 1 plus up to p base I or pi a plus p naught I. It is a sixth equation. Now we move to next equation. The coefficient of p of a can be found by evaluating f of a at the eigenvalues of a. Proof. Let lambda I be an eigenvalue of a with corresponding eigenvector vi, then lambda I vi is equals to f of a vi equals to p of a vi equals to p lambda I of vi. Now we see the eighth equation. First quality follows because f of x can be written as a Taylor expansion, and from the definition of eigenvalue avi equals to lambda I vi, this implies that f of lambda I is eigenvalue of f of a with corresponding eigenvector vi. The second quality follows from corollary 1. The third equality follows again from the definition of eigenvalue. The coefficient of p of a are the same as coefficient of p of x and can be found by solving f of lambda I equals to p of lambda I for whereas I equals to 1 to infinity or n. Okay. Now we see the conclusion. In this article, the use of Cayley-Hamilton theorem for roboticists has been explained and illustrated with some examples. The Cayley-Hamilton theorem allows to any analytic scalar function to a matrix function and compute these matrix functions in a straightforward way. Roboticists makes extensive use of exponents maps or matrix exponent and inverse of exponent map matrix logarithm. Example have been given how to implement these matrix functions with Cayley-Hamilton theorem. The appendix contains a small maple library that does not automatically for most of these functions. There exist other implementation from the literature. These other exponential of course yield the same result but were computed in less straightforward and uniform way. For other functions there are no other implementation. A good example is a Jacobian of an exponential map. Okay, I completed my topic. Thank you. Have a nice day.